When looking up to an object, the angle of elevation is formed by an observer's line of sight and a horizontal line. So before we get into the problem, I'm going to draw an image that hopefully will help you better understand what angle of elevation is. So imagine that this dot is you. So this is you. You are the observer, and you are looking up to an object. Let's call this other dot the object. The angle of elevation is the angle between the horizontal line from the observer and the line of sight to an object that is actually above the horizontal line. So here's my horizontal line. And here's the object that is above the horizontal line. So this would be my angle of elevation. So we can put, this is the angle. I'm going to call that angle theta. This is a Greek symbol for theta. So this is my angle of elevation. It makes a 90-degree angle with the ground over here. So again, this is the line of sight. And then this is the horizontal line. And if you forget, just remember that the word elevation has elevate in it. And when you elevate, you go up. So you're always looking up to an object. All right, let's get started on the first problem. So the diagram is kind of already drawn for us here, but I'm going to draw my own diagram based off of what is in the question. So it says Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So I'm going to draw my diagram. So this is Casey. Casey sights the top of an 84-foot tall lighthouse. So of course, Casey is looking up to the top of the lighthouse. This is going to be my lighthouse. And we're going to say that this lighthouse is 84 feet tall. The angle of elevation is 58 degrees. So I'm going to go ahead and draw my horizontal right here. And the angle made is 58 degrees. Casey is 6 feet tall, so I'm just going to go ahead and write that right here. Now, the actual question that is being asked is, how far is he standing from the base of the lighthouse? Remember when we talked about this, we said that base means bottom. So how far is he standing from the bottom of the lighthouse? So this right here, this is the bottom of the lighthouse. How far is he standing from the bottom? This would be x. So similar to the other problems we have solved before, we are trying to figure out which trig function we need to use in order to solve the problem. So I'm going to go ahead and write SOHCAHTOA. I'm going to try to look at my reference angle. And here, my reference angle is 58 degrees. So here I have a 58-degree angle. And in relation to this 58 degrees, 84 is my opposite. And x is my, not hypotenuse, but adjacent. So x is my adjacent side. So we have opposite and adjacent, which means we are going to use tangent. So remember, this is sine, this is cosine, and this is tangent. We're going to use tangent. And we're going to say that the tangent of our 58-degree angle is equal to opposite over adjacent. So we're going to have 84 at the top. And our adjacent side is x. We have x in the denominator. In order to get rid of this x in the denominator, we need to multiply both sides by x, which means these x's would cancel, and you're left with 84 here. And you can say that 84 is equal to x times the tangent of 58 degrees. Now, we don't have x by itself, so we actually have to perform the opposite operation. Right here, the x is being multiplied times the tangent of 58 degrees, so we're going to divide by the tangent of 58 degrees. These cancel, and we're left with x is equal to 84 divided by the tan of 58 degrees. Now, if you put this into a calculator and get the decimal approximation, you should get 52.489, which I'm going to round to 52.5. Don't forget your units, feet. So that is the distance, how far he is standing from the base of the lighthouse, 52.5 feet. Let's try another example. So number 2, this says the angle of elevation from a kicker's foot on the football field to the top of the goalpost is 17 degrees. If he is standing 131 feet from the base of the goalpost, how tall is the goalpost? So first I'm just going to draw my kicker. This is my kicker. My kicker is looking at the top of the goalpost. I'm going to try and draw a goalpost. And here's my horizontal. The angle of elevation is 17 degrees. And it says he is standing 131 feet from the base, again, that means bottom, of the goalpost. So this is the bottom of the goalpost. He is standing 131 feet, so this is 131 feet from the goalpost. How tall is the goalpost? So this is our x. How tall is the goalpost? That's what we don't know. So I'm going to write SOHCAHTOA here. Again, our reference angle this time is 17 degrees. And in relation to this 17 degrees, we know that x is our opposite and 131 is the adjacent side. So again, we will be using tangent. So we're going to say the tangent of 17 degrees is opposite over adjacent. This time x is my opposite, so x over 131. In order to get rid of this 131 in the denominator, we need to multiply both sides by 131. These cancel, and we're left with x is equal to 131 times the tan of 17 degrees. X is by itself this time, so this is our exact answer. And if you were to put it in a calculator, get the decimal approximation, you'd get 40.1 feet. Let's try another example. So this one says, Leah's mom is standing at the bottom of the slide at the playground, waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 degrees and the slide has a vertical height of 9 feet, find the length of the slide. So I'm just going to start drawing. Here's Leah's mom. That's Leah's mom. She's standing at the bottom of the slide at the playground. So here's the slide. And she is waiting for Leah to slide down. Here's Leah. Leah's up here. if the angle of elevation from the bottom of the slide to the top is 46 degrees, so you know this is our angle of elevation, it's 46 degrees. We can go ahead and draw a horizontal line. It says the slide has a vertical height. Remember, vertical is up and down. So we know that this is 9 feet. Find the length of the slide. So here's the length of the slide. That's x. Remember that this is a right angle. Now we're going to look at our reference angle. Our reference angle is 46 degrees. In relation to that 46 degrees, 9 is opposite. And x is the hypotenuse because it's across from the 9-degree angle. Here's SOHCAHTOA. We have sine, cosine, and tangent. This time we have opposite and hypotenuse, so we're going to be using sine. So we can say the sine of 46 degrees is equal to our opposite, 9, over our hypotenuse, x. So now we're going to multiply x on both sides to get rid of the x in the denominator. These cancel. We're left with x times the sine of 46 degrees is equal to 9. Divide by the sine of 46 degrees to get x by itself. So now we can write this for our final answer. And if you want the decimal approximation, put in the calculator and you should get 12.5 feet. Let's try one more example. So a dog is standing 5 feet from the base of a tree, looking up at a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground to the cat? So I'm going to draw a dog, or I'm going to try to draw a dog. This is a dog. He is standing 5 feet from the base, remember that's bottom, of a tree. So here's my tree. This is the bottom of the tree. So he's standing 5 feet from the bottom of the tree, looking up at a cat. We'll just call this the cat because I can't draw. That has climbed 16 feet up the tree. So this is 16 feet. The question is asking us, what is the angle of elevation from the point the dog is standing on the ground to the cat? So in the previous questions, we were given the angle of elevation, but this time they are asking us, what is the angle of elevation? So this is actually my x. And remember, in the trig review video, we talked about how you use regular trig when you are trying to solve for a missing side outside of the triangle, but this time you are trying to find a missing angle inside the triangle, so you should be using inverse trig. Whenever you're trying to find an angle, you're using inverse trig. So, similar to the other ones, just going to look at our reference angle. Our reference angle is x. And in relation to x, this 16 feet is our opposite. And the 5 is the adjacent side. So, here's SOHCAHTOA one more time. We have sine, we have cosine, and we have tangent. We have opposite and adjacent, so we are using tangent. So we're going to say the tangent of x degrees, which we don't know, is opposite, 16, over adjacent, 5. Now we're going to say x is the inverse tangent, not tan to the negative 1, but the inverse tan of 16 over 5. Put that into a calculator and you will get x is 72.6 degrees. This time our unit is degrees because we are solving for a missing angle. So that is angle of elevation. 17.